Hello everyone, we're discussing conduction and we have developed the formula for heat current. Heat current was T1 minus T2 temperature difference divided by R thermal. And this R thermal was L upon K. K is thermal conductivity. This is something which we developed in the previous lecture. This is the rod. Heat current is flowing through the rod. This end is at higher temperature T1, this end is at lower temperature T2, such that T1 is greater than T2. Length is L and cross-sectional area of the rod is A. When you have a steady state, that's how heat current is represented. Now, this K, which is called thermal conductivity, K is thermal conductivity, R is thermal resistance. Thermal resistance depends on length, cross-sectional area. Thermal conductivity for a given material is a constant. Write down this point. Thermal resistance depends upon shape and size of the material. Thermal resistance depends upon shape and size of the material, but thermal conductivity is constant for a given material. Thermal conductivity is a constant for a given material. Now, what type of questions you can expect from this thermal conductivity R type of thing? Suppose we have been given that T1 is 100 and T2 is 0. The question is, we have a cross section shown in red. This is the cross section, and this cross section divides the whole rod in a ratio of 3 is to 1. You identified a given cross section, and this given cross section divides the whole length in a ratio of 3 is to 1. Question is, find out temperature of this cross section when things are in equilibrium, everything is in steady state. Let's see who can answer this. And remember, this is something which you did in 10th. They would have given you a resistor, and maybe you were asked questions like this, that you have a conductor with potentials on both ends and you're supposed to answer what is the potential at a given cross section. So it's similar to that. But if you do not know what that concept was, everything is on the board. If you need any information, that is present already on the board or was discussed in the previous class. Let's see who can answer T. No response. Look here. This is the cross section we are interested in. Temperature of this portion is T. Temperature of this portion is 100. Temperature of this is 0. In this portion, heat current is I. Tell me fast in the comment box, what will be current in this? If heat current in the first portion is I, then what will be the heat current for 100 to T? This length is 3 and this length is 1. If for the 3 length you have a current of I, then what will be the current for length 1? Answer this fast. Good. It will be I only. जब सिस्टम स्टेडी स्टेट में है अपना, तो स्टेडी स्टेट का मतलब ये था, from each and every cross section current is what? Same. Which tells us what? I from this to this is 100 minus 0 divided by, let's say this length is 3L and this length is L. Automatically length ratio becomes what? 3 is to 1. I've taken this length L. You can always say L dash. Doesn't matter. So this is 3L dash and this is L dash. And you get a length ratio of what? 3 is to 1. Now, from this point to this point, what is our thermal? Length. How much is the length? From this point to this point, you have a length of 4L dash divided by K into A. Now let's talk about this portion. For this portion, what is T1 minus T2? T minus 0. T minus 0 divided by, what is the length? What is the length of this portion? L dash divided by K and A. Remember, it's the R which is going to change. K will remain same. Done. 100 by 4, 25. L dash K cancelled. This is T. So T is coming what? 25 degree Celsius. Note down this. And if you understood everything, then write down yes in the comment box. Now, this part was only 2-3 people tried to answer this thing. And only a few got it correct. But ये क्वेश्चन, ये प्रोफाइल कितना इजी है इसको समझना, and you all can answer this type of thing in just 3, 4, 5 seconds. क्या सीखना है अपने को? This R part, R is proportional to what? L. As you move from this point to this point, this end to this end, your K doesn't change, your cross-sectional area, that is also not changing. So your R is what? Proportional to L. If R is proportional to L, then what you are saying is T1 minus T2. Let's call it delta T. T1 minus T2, delta T is I multiplied by R, which is Ohm's law, V equals to IR. That V is potential difference, delta T is temperature difference. But the thing is, through every cross section I is constant, through every cross section I is constant, R is proportional to L, which tells us that this delta T is nothing but proportional to length. क्या मैंने बोला? जो टेम्परेचर डिफरेंस डेवलप होगा कहीं भी, वो किस पर डिपेंड करेगा? L, provided you have same K and same A. जो यहां पर हो भी रहा है, पूरी की पूरी रॉड का A सेम है और K सेम है. If you understand this part that delta T is proportional to L, then कितना easy है क्वेश्चन करना, सीखो. What is the temperature? 100. What is the temperature? 0. So from this point to this point, you have a fall of what? 100. How much is the drop? From 100, if you decrease 100, you get what? 0. तो आपको क्या मालूम पड़ा? आपको क्या मालूम पड़ा? That for length L, for complete length L, how much is the drop? 100. Remember, this 100 is what? Drop. Delta T. For length L, you have a drop of what? 100. अगर एक बार इतनी कहानी मिल गई कि अच्छा L पे 100 का ड्रॉप है, अगर L पे 100 का ड्रॉप है, then what is the entire length? This L is what basically, for the timing, let's say this length is 3 and this is 4, this is 1. This is 3 and this is 1. We are talking about ratios. So you are basically saying that for a length of 4, you have a drop of 100. देखना कितना पास पहुंच गए हैं अपन. For a length of 4, 3 plus 1, 4. What is the drop? 100. For a length of 4, we have a drop of 100. That means for a length of 1, how much will be the drop? 25. फिर से, for the entire length L, drop in temperature is what? 100 becomes 0 and therefore drop is 100. This is 3, this is 1. For a length of 4, drop is what? 100. For unit length, it will be what? 25. What this data says that unit length drop will be 25. यहां से यहां तक की लेंथ कितनी है भाई 1, यहां का टेम्परेचर कितना है 0, और यूनिट पे कितने का ड्रॉप हो रहा है 25, तो पक्की बात है कि यहां का टेम्परेचर क्या होगा 25 ही होगा। फिर से for length 1 how much is the drop 25, for length 3 what will be the drop 3 into 25 75, यहां से यहां तक कितने का ड्रॉप होगा 75, है कितना यहां पर 100, 100 में से 75 का ड्रॉप होगा, क्या बचा 25। नाउ इफ यू रिमेंबर दिस देन ये प्रोफाइल कितने इजी है देखना। नाउ instead of asking you whether you got this concept, I'll ask a question and let's see how many of you can answer this whole thing. We have a rod and question is that this rod has a temperature of 200 over here and this end 0. Now there are two places we are interested in. And these two places are what? 1:3:4. These two places divide the whole rod in length ratio of 1:3:4. Size पे मत जाओ, data. There are two cross sections with 1:3:4 division 1, 3, 4. Find out T1, find out T2. Should not take more than 10 seconds, but I'm giving you 30, 40, 50 seconds. Let's see how fast you are. And I don't want you to use this approach. I want you to use this shortcut approach. If they ask the question in school examination, go for the lengthy approach of R and all. But if they ask the question in an objective form, then use this. Should not take more than 30, 40 seconds. Let's see how many of you will answer this. Get me T1 and T2. Look. So let's say the whole length is what? What is the whole length? 4, 3, 7 plus 1, 8. This is the trick shortcut thing. 4 plus 3, 7 plus 1, 8. So over a length of 8, you have a drop of 200. For unit length, drop will be 200 divided by 8. 25. The moment you find drop for unit length, everything is done. What is this? This much is 4. This much is lengthwise 4. Drop will be 4 into 25. For unit length, drop is 25. 4 into 25 is 100. From this point to this point, you have a drop of 100. After a drop of 100, temperature becomes what? 0 degrees Celsius. What should be the temperature? It should be 100 only. This length is 3. If this length is 3, then it means this length is 7. 3 plus 4, 7. For 7, your drop will be what? 7 into 25. What is 7 into 25? 175. यहाँ से यहाँ तक कितने का ड्रॉप है? 175. And after that it becomes what? 0. इस जगह का टेम्परेचर क्या होगा? 175. खत्म. Done. We have found the temperature as 175 and 100. Note down this. Now write down series combination of thermal resistors. Series combination of thermal resistors. That's how you represented resistors in 10th. And the basic and the most important thing was all resistors had same current. So when you talk about series, I should be same. But what basically meaning of series is, or the equivalent thing we are interested in, so that look here. So you have a rod. Its thermal resistance is R1. Then you connect another rod. Its resistance is R2. You connect another rod. Its resistance is R3. Temperature at this end is T1. Temperature at this end is T2. The thing is, we need to replace the whole thing with a single rod such that overall behavior of the system is same. What is the meaning of overall behavior? यहाँ चलते हैं, ये अपने को समझाएगा क्यों हम combinations के पास जाते हैं. Just imagine that this is your steam box and this is an ice box. Steam, ice. And what you found that when you have three rods R1, R2, R3, you found that 10 grams of ice melts every second. Remember, what did I say? यहाँ पर स्टीम बॉक्स है, यहाँ आइस बॉक्स है, और हमने क्या देखा कि इस आइस बॉक्स में से 10 grams आइस हर सेकंड क्या हो रही थी? मेल्ट. Now what you did, you replaced these three rods with a single rod. And you connected this rod between this same steam box and ice box, and you found that again 10 grams of ice per second melts. This is your overall behavior. इसका मतलब आप ये तीनों रख लो या अकेली रॉड रख लो, हमारा ऑब्जर्वेशन जो है सिस्टम का वो क्या बना हुआ है? सेम. Then we say that this R total is the equivalent resistance of R1, R2, R3 in series. So we need to find this R total. अपने को अगर ये R total find करना है और हर सेकंड में सेम हीट फ्लो हो रही है क्योंकि सेम आइस मेल्ट हो रही थी, तो इसका बेसिक मीनिंग ये है that from this, in the first one, heat current is I. In the second one, heat current is I. In the third one, heat current is I. Because they are in which combination? Series. heat current will be same, and same heat current is present in the equivalent rod. I हो क्या रहा था 20 joules per second. What is I? dq by dt, joules per second. 20 joules per second सप्लाई हो रही है, उससे 10 ग्राम साइज मेल्ट हो रही थी. अभी भी 20 joules per second सप्लाई हो रही है, सेम आइस क्या हो रही है, मेल्ट. So what should be our total so that your I doesn't change? That's what the question is, and that's what we need. Although you already know what the answer will be, but that's how we handle the whole part. So this is T1, this is T2. Let's say temperature of this end is T dash, and temperature of this end is T double dash. T dash, T double dash. These are the temperatures. These are the temperatures then for the equivalent rod. What is I? T1 minus T2 divided by R total. What is I? T1 minus T2 divided by R total. For the first rod, what is I? T1 minus T dash divided by R1. What is I? T1 minus T dash. For this entire portion, your resistance is what R1. Temperature difference T1 minus T dash divided by R1. For the second one, this I is T dash minus T double dash divided by R2. And similarly for the last rod, T double dash minus T2, T double dash minus T2 divided by R3. Easy है, समझ में आया होगा, इन तीनों के लिए एक ही चीज है. Now, what is this? T1 minus T2. What we can do is T1 minus T2 is nothing but T1 minus T dash plus T dash minus T double dash plus T double dash minus T2. तो यहां से यहां तक का ड्रॉप चाहिए था. हमने बोला यहां से यहां तक का ड्रॉप क्या होगा, यहां से यहां तक का ड्रॉप प्लस यहां से यहां तक का ड्रॉप प्लस यहां से यहां तक का ड्रॉप. कोई स्पेशल चीज नहीं है. तो यहां से यहां तक का हाइट डिफरेंस कितना है, हमने बोला एक काम करो, यहां से यहां तक का निकाल दो प्लस यहां से यहां तक का निकाल दो प्लस यहां से यहां तक का निकाल दो और तीनों को क्या कर दो, ऐड. दैट्स व्हाट इज हैपनिंग. So we have found T1 minus T dash plus T dash minus T double dash plus T double dash minus T2. That gives us what? Entire drop. क्यों किया हमने ऐसा? What is T1 minus T2? I into R total. What is T1 minus T dash? IR1. What is T dash minus T double dash? IR2. ये क्या होगा, IR3. I cancelled, and you got R total as R1 plus R2 plus R3. आपने इस चीज को करंट में देखा हुआ है. आप इसी चीज को फिर से 12th में देखोगे इसी तरह से. The only change will be I will replace T1 T1 with V1, T2 with V2. This will be V dash and this will be V double dash. Are you comfortable with this derivation? Yes or no? Fast. Now the next thing in this article is what? Thermal conductivity. Thermal conductivity of this first rod is K1. Thermal conductivity of the second rod is K2. Thermal conductivity of the third rod is K3. And one more thing. The first rod, its length is L1, second rod length is L2, third rod length is L3. And they must have same cross-sectional area. Why? If you have same cross-sectional area, then all the heat coming from the first rod can enter the second rod. Imagine a situation like this. You have a rod and then you connected it with a rod with larger cross-sectional area. Then just imagine heat coming through this end, this side. Then this much heat is lost. So what we do, we always connect rods with same cross-sectional areas, A. But lengths can be different, L1, L2, L3. Thermal conductivities are K1, K2, K3. The question is, you need to find K total. What is the equivalent thermal conductivity? K total. K total, we have found R total. Now get me K total. Let's see how many of you can do that. Should not take more than 30 seconds. Look here. What is R total? R1 plus R2 plus R3. What is R1? L1 upon K1 into A. That's how you define resistance. What is R2? L2 upon K2A. What is R3? L3 upon K3A. What is R total? What is this length? This length must be L1 plus L2 plus L3. Remember, what was the statement? You have a steam box, you have an ice box, and they are connected by 3 rods. You remove these 3 rods and then you connect those boxes with a single rod. So what is the length of this single rod? L1 plus L2 plus L3. And it must have same cross-sectional area A. So what is our total? Length. What is the length? L1 plus L2 plus L3 whole divided by K total into A. So you have a rod of length L1 plus L2 plus L3, its cross-sectional area is A, its thermal conductivity is K total. A, cancel. Your K total is coming. Your K total is coming L1 plus L2 plus L3 whole divided by L1 plus L2 plus L3, move K total over here, shift the whole thing, right, the denominator, and you get what? L1 upon K1, L2 upon K2, L3 upon K3. That's your K total. L1 plus L2 plus L3 whole divided by L1 upon K1 plus L2 upon K2 plus L3 upon K3. A very easy derivation for school examination. You can expect a question like this. The only thing you need to do is what? Write down R total and then put all these values in terms of L and K. Note down this and then we'll discuss parallel combination. Those of you who are fast, try to find the formula of R total in parallel combination. You already know what it should look like. 1 upon R plus 1 upon R. And also find K total. I'm giving you the figure for that. Suppose the way you connect resistors in parallel was this. This is called parallel combination. So now what you can do is you have a rod, take another rod, take another rod. This will be called what? Parallel combination. This is your steam box. This is your ice box. Steam, ice. If you want to connect these two boxes in parallel combination, then all rods should be of same length. They can have what? Different cross-sectional areas. So note down this thermal conductivity part, and then this is R1, this is R2, this is R3. You already know 1 upon R total is 1 upon R1 plus 1 upon R2 plus 1 upon R3. This is what you need to develop, and once you get that formula, you will write yes in the comment box. I'm giving you around 1 minute's time. Let's see how many of you can develop R total for parallel combination. Now let's talk about parallel combination. This is parallel combination. There are several rods. The first was this series, and now we have parallel combination. This rod, its resistance is R1. Second rod, resistance is R2. Third rod, you can have any number of rods, but we'll take 3 only. Third rod, its resistance is R3. Now, what did I tell you? This side you have a steam box. What it says, this is at T1 temperature, this is also at T1 temperature, this is also at T1 temperature. Temperature of steam is what? 100, 100, 100, 100. This side is the ice box. If this side is the ice box, then every cross section over here is at a temperature of T2, 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 which means delta T, delta T, delta T is same. So in parallel combination, what is same? For resistors where current flows, electric current, potential difference. For resistors where heat current flows, temperature difference. Now, from the first, a current of I1 flows. From the second one, I2. From the third one, I3. And our aim is to find what equivalent of this setup. What is the equivalent setup? Equivalent setup is this. I mean, you can draw just under this parallel combination or whatever you wish. This is the equivalent setup. Equivalent setup where this end is at T1 temperature, this end is at T2 temperature, and resistance of this thing is what? R total, and current which is flowing through this is I. Three lines means this whole setup is equivalent to this. This whole setup is equivalent to this. And everything looks exactly same. Let's redraw this thing. Let's draw the whole thing this way so that we can use the concept for conductivity, thermal conductivity part also. So we want to replace the whole setup where this cross section is A1, this cross section is A2, this cross section is A3. We want to replace the whole setup with a cross sectional area of A1 plus A2 plus A3. Length should remain L. This end is T1, this end is T2, and current which is flowing is I. We'll need A1, A2, A3 when we decide K total. Right now we are interested in R total part. We need to find R total. So you've got three dots having R1, R2, R3 thermal resistances. Remove these three, connect a single rod, and what you found? Same amount of ice melts in unit time. Same concept कि वही 10 grams per second ice melt हो रही थी. तो हमने क्या बोला? हमने बोला एक काम करो, क्यों ये तीन रॉड लगाए, हटाओ एक रॉड लगा दो. What should be R total of the equivalent rod so that overall behavior doesn't change? That's what the question is. So this is the question. Then what? What is the current I1? What is the current I2? What is the current I3? These three currents are basically doing what? This heat flows into the ice box and then ice melts. So how much heat you are basically collecting? I1 plus I2 plus I3. This is the theme for parallel combination. I1, I2, I3 ये तीनों जाकर कहाँ पहुंच रहे हैं? In that ice box. In the equivalent one you are saying only I is present. So if you want to melt same amount of ice, this I should be same as I1 plus I2 plus I3. थोड़ी देर के लिए just let's assume what ये 10 joules per second था, ये 20 joules per second था, ये 30 joules per second. Heat current dq by dt, dq joules dt second, 10 joules per second, 20 joules per second, 30 joules per second. And just for the time being, assume that this 10 joules is going to melt 10 grams of ice. मान लिया थोड़ी देर के लिए 20 joules is going to melt 20 grams, 30 joules is going to melt 30 grams of ice. तो फिर यहां पर आपको क्या करना पड़ेगा? You need to melt same amount of ice. How much is that? 30 grams, 20 grams and 10 grams. For that, your I should be equal to I1 plus I2 plus I3. But now question is done. What is I? I is delta T divided by R total. Remember, delta T in parallel combination is what? Same. What is I? Delta T upon R total. What is I1? Delta T upon R1. Delta T upon R1. Delta T upon R2. Delta T upon R3. एक सेकंड की कहानी है, बाकी तो समझाने में टाइम लगा. Temperature difference T1 minus T2, which is delta T. Temperature difference T1 minus T2, which is also what? Delta T. Delta cancelled and you got 1 upon R total as what? 1 upon R1 plus 1 upon R2 plus 1 upon R3. एक लाइन की कहानी है basically. Now tell me, how many of you got it correct? How many of you got this I, this 1 upon R total? If you could, write down yours in the comment box now. Now get me K total. Get me K total in terms of K1, K2, K3. K total in terms of K1, K2, K3. K total in terms of K1, K2, K3. Should not take more than 30 seconds now because procedure is same. Look here. What is 1 upon R total? This rod, the equivalent rod of length L, and this is the cross-sectional area. So what is 1 upon R total? 1 upon length divided by, let's save time, divided by means it will appear in the numerator. This is 1 upon R total, and therefore I can always write L K total multiplied by A. But what is A? This time your A is A1 plus A2 plus A3. 1 upon R total is this. What is the entire cross-sectional area? This is equal to what? 1 upon R1. For the individual rods, what is 1 upon R1? 1 upon R1 is what? L K1 A1, K2, A2, and so on. K3, A3, K4, A4. You got the answer. L cancelled. Your K total is coming K1, A1 plus K2, A2 plus K3, A3 plus K4, A4 जितने भी हैं divided by A1 plus A2 plus A3 plus A4. That's how we develop equivalent thermal conductivity. So how many of you got this? K total as K1A1 plus K2A2 all divided by A1 plus A2. If you could, write yes in the comment box fast. Note down this question. There are three dots with these lengths and thermal conductivities, and they have same cross sectional area, say 2. 2, 2, 2, 2. Temperature of this end is 120 degrees Celsius. Temperature of this end is 0. Find out temperature of this interface and temperature of this interface. I need T1 and T2. If the lengths, conductivities, temperatures, cross-sectional areas, find out temperature of this junction and this T1 and T2. Begnavi, taking too long. What is R1? L1, K1, A. That's your R1. L upon K. What is R2? L, A. What is R3? L, K, A. अच्छा R1, R2 and R3. This third rod has the highest thermal conductivity. लेकिन उससे अपने को कुछ नहीं. अगर कनेक्शन सीरीज है तो फिर इन तीनों से कितना करंट फ्लो होगा? I. तो अगर तीनों से सेम ही करंट फ्लो होना है, ये रहा तरीका. क्या फाइंड करना है अपने को? I. We need T1, T2, but what is I? What is I for the first rod? Delta T. Delta T divided by R1. What is I for the second rod? Delta T divided by resistance. What is I for the third rod? T2 minus 0 divided by resistance 3 by 2. Delta T divided by resistance, delta T divided by resistance, delta T divided by resistance. How many unknowns are there? 2. How many equations you need? 2. How many unknowns are there? 2. How many equations you need to solve for this? 2. Well, how many equations have we got? Who can tell me how many equations are present? If you want to solve T1 and T2, then do we have the sufficient data? 2 unknowns require at least 2 equations. So how many equations have you got? 1, 2, 3, 4. How many equations are present? Who can tell me? Good, there are 3. But basically there are 2. क्या क्या equations हैं? Equation देखना कितनी है? This term is A, this term is B, and this term is C. The first equation is A equals to B. And the second equation is what? B equals to C. And third is not an independent one. Third is what? A equals to C, which is coming from these two only. So it looks as if you have got only one. No, remember this is giving you 2 equations, and therefore there are 2 unknowns. Anybody can solve this question. Anybody can solve this question using this. क्या करना? This and this, they are equal. Find a relation between T1 and T2. This and this, they are equal. Find another relation between T1 and T2. So you've got 2 relations. Solve those relations and you will find T1 and T2. Not a big task. But we are not interested in this type of thing for this particular data set. In fact, you can use the technique for any type of data set. But go down this fast and then we'll see a shortcut method. A one-line method basically. Go down this fast. Take a screenshot. Look at the shortcut. Let's say R1 is R. R1 is what? R. 1 by 2. What is this? 2 multiplied by half. That means what is R2? 2R. ये half है, 1 है, double है. What is R3? 3R. This is 3 by 2. So 1 by 2 is R, 2 by 2 is 2R and 3 by 2 is 3R. बहुत सही. अगर ऐसा है तो अपने को क्या चीज मिल गई? अपने को ये मिल गया. Temperature over here is 120 and temperature at this place is 0. This is 120, this is 0. This is R, this is 2R, this is 3R. R, 2R, 3R. What is R total? R plus 2R plus 3R. Which is what? 6R. R plus 2R plus 3R. Which is coming what? 6R. Now, what is delta T? Delta T is I multiplied by R. Ohm's law. Remember that way. Which means potential difference is basically proportional to what? Thermal resistance, not this R. It tells you what? That potential temperature difference is directly proportional to what? Resistance. Provided you have same I. थोड़ी देर पहले हमने यूज किया था इसी चीज को. तीनों में करंट क्या है? सेम. इसका मतलब डेल्टा टी किसके प्रोपोर्शनल है? आर के. तो डेल्टा टी आर के प्रोपोर्शनल है, then what you're saying, from this end to that end, how much is the drop? 120. And what is the resistance? 6R. 6R. So what is the drop? Drop is of 120 for a resistance of 6R. Theme. What is the resistance of the entire combination? 6R. What is the drop from this point to this point? 120. For 6R you have a drop of 120, then for R your drop will be what? 20. यही चाहिए था अपने को. यहां कितना है? 120. What is the resistance of this part? R. For R, how much is the drop? 20. 120 में 20 का ड्रॉप होगा तो बचेगा क्या? 100. ये तो R है ना भाई. अब या तो यहां से चलो या यहां से चलो, आपकी मर्जी है. What is the resistance of this part? 3R. R पर कितने का ड्रॉप है? 20. 3R पर क्या होगा? 60. R 20, 3R 60. यहां का कुछ टेम्परेचर था, 60 का ड्रॉप हुआ and it became what? 0. Well, it can only be what? 60. Done. Yes. Do the same thing from this end also. This is R. This is what? 2R. So how much is this? 3R. For R, this is a drop of 20. For 3R, drop will be what? 60. Temperature is 120. After a drop of 60, it becomes what? 60. Now, ये थीम एक बार क्लियर हो जाए तो ये सब इक्वेशन और बनाने की जरूरत नहीं है. You don't even need to find R. Just look at the data. Look at the data, especially 114293. It is basically telling you that your resistances are giving you a kind of ratio setup where things can be easily calculated. You don't have to make two equations and then solve those equations and all. That will take time. If you are looking for an objective examination, if you are looking for a school examination, definitely go for that. Develop equations, solve those equations. But for competitive examinations, R, 2R, 3R, in just 15-20 seconds, of course, with practice. With practice, you can solve these questions very easily. If you are comfortable with this second trick method, write down yes in the comment box and then you can leave. Thank you very much.